Hi Year 11s, welcome to Jog Your Memory series where we're going to help you guys go over some of the things that you're finding most tricky. So you did a Google Forms and you voted on the topics you found most difficult, and our first one, most tricky, which somewhat unsurprisingly is atmospheric circulation models. So I'd like you to have your Jog Your Memory sheet in front of you, and as you can see on there, we want you to take notes during the video. We want you to do a few exercises while you're doing the video, so task 1 and 2, and then task 3 and 4 are for you guys to do after to really test your understanding. Okay, so those are the steps that we want you to take during this exercise. So there's two key things that we want you to understand when we're thinking about global atmospheric circulation. And the first is latitude and how it affects climate. So in your first task, we want you to look at the pattern. What can you see on this map in terms of a pattern? Remember that this line going through the middle here is the equator. Okay, so think about how that might affect climate. So I'll give you a couple of minutes just to write down some ideas about how latitude affects climate. So the first thing that you might have noticed is that around the equator temperatures are highest, north and south, just off the equator, and as you get further away from the equator, 0 degrees latitude, it tends to get cooler. Now that's a general pattern, it's not strictly true for everywhere, but the general pattern is as you get further away from the equator, things tend to cool. If you're not too sure what latitude is, can you just jot down this definition for us? So there's a definition on the right coming up. So latitude is the distance north or south of the equator. It's measured in degrees. So for example, London is 51 degrees north of the equator. And as I said, you should have seen the temperature varies with latitude. As we get further away from the equator, it tends to get cooler. So the second thing you really need to understand alongside latitude is differential heating. Okay, so this is an example of differential heating, and so your task 2 is to think about what's going on here. Right, so differential heating is the fact that different parts of the Earth get different amounts of radiation and they are therefore hotter or colder, just as we've seen from our latitude exercise. But you need to be able to explain why. Okay, because the same amounts of radiation are coming from the sun, but they are affecting the climate in different ways. So the first reason for the differential heating is because of Earth's curvature. We all know that the Earth is round, and as a result of this, we get different amounts of concentrated radiation. In the poles, as you can see from the diagram, the same amount of radiation, so these lines here, is coming from space, from the sun. Okay, but if you look at how it's spread over the area, it's spread over a much larger area. And I always think back to like squash or Ribena. If you have a little bit of Ribena in your drinks with lots of water, then it's much weaker. Okay, same's true of radiation. So when we have an amount of radiation spread over a large area, it's much weaker and therefore it's much cooler. At the equator, the sun shines from directly above. Okay, so between the tropics, it shines from directly overhead, and so it's concentrated in a small area, and as a result, it's much hotter. And that is your first reason for differential heating. Okay, so the Earth's curvature means the equator receives more concentrated radiation from the sun. The second is that there's a longer distance for the radiation to travel through the atmosphere. Okay, so further distance here, for example, at the top than at the equator. And what that means is that the atmosphere acts like a bit of a barrier. So more radiation is reflected back into space because it has to travel through more atmosphere. And as a result, it's much cooler. Okay, so I said at the poles, radiation has to travel through more atmosphere, so less energy reaches the Earth, and therefore there are cooler temperatures. Okay, so two reasons for differential heating. Okay, so now that we've got those basics, we need to understand what the atmospheric circulation model does. And it really is, it's so important for us to understand as geographers because it links to so many different things. You'll see it in your paper 3 at the moment as to why there's different biomes in different areas, because that heat from the sun is being transferred through the atmosphere into different areas. And it's being transferred by 3 different cells. As you can see on the diagram, we've got the Hadley cell, we've got the polar cell, and we've got the feral cell. And I'm going to explain each one as we go along. What I'd like you to do is just to take notes on each one, and then at the end of the exercise you're going to replicate a diagram for me. Okay, so explaining the Hadley cell. This is our first one where we're going to start from. The Hadley cell is a thermally direct cell. It is driven by the force of the sun's radiation. Okay, so we know that at the equator the Earth receives its most of radiation. Okay, and what that means is that we get hot air rising. Okay, first rule, hot air rises. You know it from hot air balloons and so on. So at the equator we get more hot air rising. The next thing that happens is that as that hot air rises, it starts to cool because it's at higher altitude. And so when we get cooling of the air, that then leads to condensation. So we get, at the equator, we get very hot areas with convectional rainfall. Lots of rainfall over the equator because we've got convectional rainfall, hot air rising, cooling and condensing, forming rain clouds. But that's not the only part of our Hadley cell. The air rises, and what happens is it kind of hits a part of the atmosphere called the troposphere, and this kind of acts like a roof, and it can't go any further up, it can't rise further. So what it does is it circulates both north and south of the equator. Okay, but as it moves away from the equator, it starts to cool. Okay, so cooling air creates high pressure, and so as that air falls, it creates a high pressure, and high means dry. So along these tropic areas, so this is the Tropic of Cancer, okay, so along here, Tropic of Cancer, we get an area of high pressure, which means very dry climates. And that's where most of the world's deserts form, along the Tropic of Cancer and Tropic of Capricorn, because the air is descending, it's creating high pressure. And it's much drier because descending air, which is starting to warm up, can actually hold more moisture, and as a result we get deserts forming along the tropics. The last part of the Hadley cell is that air then circulates back as trade winds towards the equator, because air always moves from high pressure to low pressure. If you think about me blowing up a balloon, there's high pressure inside the balloon, I let go of the balloon, and then that air comes out of the balloon into the low pressure area in my room. So air will move back from high pressure to low pressure, and that creates our Hadley cell. So we're now going to look at our second cell, which is going to be the polar cell. Okay, so in the far northern latitudes of the world, the polar cell. So as part of the polar cell, what we have is we have an area where we know it's getting less radiation. There's less heat from the sun coming to Earth in the far northern parts of the world, and what that means is that cold air is going to sink. Okay, so we have high pressure right at the poles, high meaning dry, okay, but we've got high pressure where the air is descending towards the Earth. What that means is we know from our previous example is air always moves from high pressure to low pressure. So the highest pressure is at the poles because it's coldest and the air is falling, and so the air circulates back south towards places like Britain. Okay, as it moves south, it's moving away from the poles towards the equator, and therefore it starts to warm. What do we know happens when air warms? Well, it starts to rise. Okay, so we get our rising air creating low pressure. Okay, and then finally that air circulates back to the poles to form the polar cells, and it's much more sort of straightforward than the first one if you've understood what the Hadley cell does. So this one is also thermally direct. Okay, so the polar cell is thermally direct, but it's driven because it doesn't get much energy from the sun, whereas the Hadley cell gets lots of energy from the sun and is therefore driven by the sun as well. Our third cell is the feral cell. This one is thermally indirect. It's not affected by the sun. The reason it circulates is because of the two circulations of our polar cells and our Hadley cell. Those two circulating movements of air cause the feral cell to rotate. Okay, so you've got this rotation of the air within the feral cell, and that completes your air circulation model. So you've got at the equator and between the tropics, you've got your Hadley cell. In the far northern latitudes, you've got your polar cell, and then you've got your feral cell in between. So what I hope you've done is taken down lots of notes on each of these cells, and I'd like you to now move on to the exercises below. Okay, so you've got some multiple choice questions, and then you've got a diagram that I'd like you to complete. Try to do it without your notes or without looking at these diagrams here. Try to see how much you remember. And then the last bit is fill the gaps so that you've got a really good description of the air circulation model in your notes. Okay, so hopefully you've had a go at these multiple choice questions. Some of them more straightforward than others, but we want you to check your answers. I want you to correct it in a different color pen, so green pen would be great, just to make sure you've got those answers. There's no point just writing down the answers just for the sake of it. Okay, have a go at them first and then correct it yourself. So once you've done those questions, check your answers with the following. Next exercise is for you guys to do your diagram. So I want you to add those labels to your diagram. Again, try to do it without your notes. This is about you recapping stuff in your mind, going over things and really testing yourself. Okay, so those are the words at the top. I want you to add it to your diagram. Do your best and then check on this video to think about going back over and make sure your answers are correct. So wind back the video if you want to check your answers. The last thing from me is your fill in the blanks. So this exercise, again, spend a bit of time reading it through, look at the keywords, really try to have a go without looking at your notes or looking at the answers. I will load up the answers in a minute for you guys to check your own answers. Okay, well done everyone. So answers. So check your answers, make sure you're happy with it, and hopefully this video will mean that you are feeling more confident about global atmospheric circulations. Well done everyone, see you soon.